All right, so this is the first video on how to fill out a unit circle. This video is going to be the long and hard way to do it, where we are actually relating things back to like using special right triangle rules to try to figure out some of the things in this. I definitely would not recommend using this method anytime you want to fill out the unit circle, just because it's going to take so long. But hopefully you do want to deepen your understanding of how this actually works. That will make you a better mathematician. That will make you a better calculus student. So please pay attention to this. I'm going to start off by filling out the degrees. Sorry, not the degrees, the angles. You might have heard me say in class that I don't actually care about the degrees, and that's because in calculus we almost never use degrees. I don't know if I used degrees at all the last year that I taught BC. So radians is what you want to worry about. A quick explanation of what radians are. So the term unit circle, unit means 1, and that's the radius. So a unit circle is just a circle with a radius of 1. Well, if we think about the circumference, you might remember that the circumference of a circle is equal to 2 pi r. That's the distance all the way around a circle. Well, if our radius is 1, that means that our circumference is 2 pi times 1, which is just 2 pi. So if I go all the way around a unit circle, if I start off at 0, and if I go all the way around it, I'm going to go counterclockwise, I would stop right where I began, and then I would have traveled a distance of 2 pi. So if you go all the way around the edge of a unit circle, you've traveled 2 pi. And that's actually what radians are. Radians is the distance traveled around the outside of that unit circle in terms of pi. So if you think about it, if a full circle is 2 pi, well then half a circle would just be half of that 2 pi. And half of 2 pi is pi. So over here on the left, at 180 degrees, half of a circle, that's just pi radians. If I cut that in half, I'd be up here at the 90-degree angle. So half of pi would be pi over 2. And then if I cut the pi over 2 in half, that's the 90-degree angle. If I cut 90 degrees in half, that'd be 45 degrees. And pi over 2 divided by 2 is pi over 4. So that'd be here. So now that I know that this middle line of each quadrant is just a pi over 4 length, I could actually go through the entire circle just counting out the pi over 4 lines. Sorry, counting by pi over 4 to hit those middle lines. So if I start off here, this would be pi over 4. And then I'm going to skip the 30-degree lines. So I'm skipping this one. And then this one, if I count by pi over 4 plus another pi over 4 is 2 pi over 4. Well, if you reduce 2 pi over 4, that gives you that pi over 2 that we have here. And then we're going to skip this next line, go to the middle line here. And then I've got 2 pi over 4 plus another pi over 4. That would be 3 pi over 4. Skip the next line, go down to this far left point. I'm going to call that a cardinal point. If you go straight up, down, left, or right, those are cardinal points. So 3 pi over 4 plus another pi over 4 would be 4 pi over 4, which reduces to pi. We already have that written. And then if we skip the next line, 4 pi over 4 plus pi over 4 is 5 pi over 4. Five pi over 4 plus another pi over 4, that's going to be 6 pi over 4. But if we reduce that fraction, you can divide the top and the bottom by 2. That would give us 3 pi over 2. And then if I have the 6 pi over 4 plus another pi over 4, that would be 7 pi over 4. So that's the middle one right here. And then 7 pi over 4 plus pi over 4 would give us 8 pi over 4. and that reduces to just 2 pi, which we already have written. So that's all of the pi over 4 angles figured out. That's the middle lines inside of each quadrant, plus the cardinal points. So now I'm going to ignore those for a moment, and I'm going to do the other ones. I'm just going to concentrate on the angles that we do not have filled in. So let's go back to this pi over here. And if you look at the pi and then look at how many of these 30-degree lines are, that's the 1/3 lines inside of each quadrant. So if we start at the first quadrant, there's 1 here, and then we have 2. You got to hit the top one here. That's 3, 4, 5, and 6. So it takes 6 of those lines to get to pi. And each of these are the same distance apart. The angles are all the angles between each pair is the same. So that means that the angles of each pair must be pi over 6. So then this first one up here would be pi over 6. And then we're just going to count by pi over 6 to hit each of these 1/3 lines. So pi over 6 plus pi over 6 would be 2 pi over 6. But if you reduce 2 pi over 6 by dividing the top and the bottom by 2, you would have pi over 3. And then 2 pi over 6 plus pi over 6 would be 3 pi over 6. Well, 3 pi over 6 would reduce pi over 2. We already have pi over 2 written at the top. And then 3 pi over 6 plus pi over 6 would be 4 pi over 6. And that reduces to 2 pi over 3. Just divide the top and the bottom by 2. And then 4 pi over 6 plus another pi over 6 would be 5 pi over 6. And then if you add another pi over 6, that gives you 6 pi over 6, which is the same thing as pi. That's already written. Plus another pi over 6, so 6 pi over 6 plus pi over 6 is 7 pi over 6. And then the next one would be 8 pi over 6. But that reduces, divide the top and the bottom by 2, that would be 4 pi over 3. Next would be 9 pi over 6, but that reduces to 3 pi over 2. We would then have 10 pi over 6, which reduces to 5 pi over 3. And then finally, 11 pi over 6 is the last one that hasn't been filled in. If you counted one more, we'd have 12 pi over 6, which reduces to 2 pi. So that is all of your radians filled in. Now we have to worry about the coordinates. All right. So, like I said, this is not the ideal way to do this if you're just trying to quickly fill out a unit circle to try to solve something, or if you're trying to fill out the unit circle on a quiz. Don't use this method, but try to understand this method just so that you'll have a deeper understanding of how unit circles work. So what I'm going to do is I'm going to start off with this first line here, the pi over 6, and I'm going to turn this into a triangle. So from the coordinate, I went straight down, and then I went straight left, and I'm using that line there as my hypotenuse. And what I've done is I've created a right triangle. And if this is pi over 6, well, pi over 6 is a degree, relating it back to the degrees for the special right triangles. Pi over 6 is 30 degrees. So what we have here is a right triangle that has a 30 degree in it. Well, this has to be a 30, 60, 90 triangle. Since this is a 30, 60, 90 triangle, we can use the 30, 60, 90 special right triangle properties to find the lengths of all the sides. Keep in mind, this is the unit circle. Unit circle has a radius of 1. The hypotenuse of this is the radius of the circle. So the hypotenuse of this 30, 60, 90 triangle has to be equal to 1. Well, we know that everything goes through the short leg. So if I go opposite the 30 degrees, that's going to give me the short leg. And I don't know the short leg in this case. But I know if I were to double the short leg, that gives me the hypotenuse. And I know the hypotenuse is 1. So if I work backwards, instead of multiplying times 2 to get to the hypotenuse, I'm going to divide by 2 to get to the short leg. That means that this short leg over here has to be a half. And now that I know the short leg, I can find the longer leg just by multiplying that times root 3. So this would be root 3 times a half, which we could just write as root 3 over 2. Well, the 1/2 here, this corresponds to the vertical distance from the x-axis to that coordinate. Well, that's just the y-coordinate itself right here, 1/2. And then the root 3 over 2, that corresponds to the horizontal distance from the origin to the coordinate. So that would be the root 3 over 2 as the x-coordinate. And there you go. We have figured out the first coordinate there using 30, 60, 90 properties. And of course, the fact that this is a unit circle which has a radius of 1. So then we can extend what we know about this one point to all of the other points inside of the circle that would be part of that 30, 60, 90 triangle. So if you think about it, this right here would be the same triangle with your 30 degrees being right here in the center. So the coordinate here would still be root 3 over 2.5. But you got to be careful. We're now in the second quadrant. And if you're in the second quadrant, x values are actually negative. So we need to make that x value negative, but you're leaving the y coordinate positive. Well, there's actually two other coordinates that are the same, that also have this 30, 60, 90 triangle. So there's one in the third quadrant, and then there's one in the fourth quadrant. So all of those coordinates that are closest to the x-axis all have those root 3 over 2 and 1/2 coordinates. You just have to make sure that you're putting the signs in that coordinate correctly. If you're in the third quadrant, both x and y are negative. So I just need to put a negative in front of the root 3 over 2 and a negative in front of the 1/2. And then over here, it's still root 3 over 2 and 1/2. But now in the fourth quadrant, x is positive, but y is negative. So I need to put a negative sign in front of the y. So we've got that figured out. So I'm going to erase these triangles because I don't need these anymore. All that was just to try to figure out what the coordinates were. Okay, so now let's move on to the, let's do the pi over 3 next. You're going to find that the pi over 3 is really, really similar to what we just did here. Let's draw a triangle. Going straight down from that coordinate, down to the x-axis, and then straight over to the origin. So this is the pi over 3 angle, which is the same thing as 60 degrees. So that central angle there at the origin, that is 60 degrees. So we're still looking at a 30, 60, 90 triangle. We have a right angle, we have a 60 degrees. The sum of the angles inside of a triangle has to equal 180 degrees. That means that this angle up top here has to be 30. And the radius, the hypotenuse here, is still 1. So the values inside of this triangle are the same as the last one. It's just that, a couple of the numbers have been flipped. They've been transposed. So the 1/2 that we had before as a y-coordinate, that's actually going to be our x-coordinate. If you go opposite the 30 degrees, that's your short leg. So you have to divide the hypotenuse by 2. 1 divided by 2 is equal to 1/2. So that is our x-coordinate, 1/2. And then if you multiply 1/2 times root 3, that would give you root 3 over 2, and that's the distance for the other leg, which is corresponding to the y distance from the x-axis to the coordinate. So the y coordinate here is root 3 over 2. And then we could actually draw similar triangles in all the other quadrants, hitting those top coordinates within each quadrant. So then I can actually just copy over that 1/2 root 3 over 2 into all of these other coordinates, just making sure that I'm putting the sign correctly for each one. So if I'm in the second quadrant, the x is negative, y is positive. Third quadrant, 1/2 root 3 over 2, but they're both negative. Fourth quadrant, 1/2 root 3 over 2, x is positive, y is negative. All right, I'm gonna erase all this. So we've only got a couple left here. I'm gonna save the easiest ones for last. So let's do the middle one here. That's the pi over 4 angle. So I'm gonna draw straight down from the coordinate, down to the x-axis, and I'm gonna go left to the origin, and then I'm gonna use this pi over 4 line as my hypotenuse. Pi over 4 is the same thing as 45 degrees. So if I have 45 degrees and a right angle, that means the other angle has to also be 45 degrees. I'm looking at a 45, 45, 90 triangle here, with the hypotenuse the same as the radius, equal to 1. Well, you might remember from the last video that if you want to go from a leg in the 45, 45, 90 triangle to the hypotenuse, you have to multiply times root 2. Well, we are working backwards. So instead of multiplying times root 2, we are going to divide by root 2. That'll take us from the hypotenuse to the legs. So if I take 1 and divide it by root 2, that would give me 1 over root 2. If we rationalize that, that would be root 2 over 2. To rationalize, you just multiply the top and the bottom times whatever the radical is in the bottom. That reduces down to root 2 over 2. And since this is a 45, 45, 90 triangle, both of the legs have that length, root 2 over 2. So that gives us the x-coordinate and the y-coordinate. That's the distance traveled in the horizontal distance, in the horizontal direction from the origin to the coordinate, and then the distance traveled in the vertical direction from the origin to the coordinate. And then all of the middle coordinates here are going to have the same values. It's going to be root 2 over 2, root 2 over 2. If you're in the second quadrant, x has to be negative. Root 2 over 2, root 2 over 2. If you're in the third quadrant, both x and y are negative. And then root 2 over 2, root 2 over 2. The fourth quadrant, x is positive, y is negative. So there's only one thing left here, and that is the cardinal points. Cardinal directions, if you think of like a compass, your cardinal directions are north, south, east, and west. The cardinal points here are kind of like that. It's just going straight up, down, left, or right from the origin. So if I'm looking at this coordinate here at 0 radians, same thing as at 2 pi radians, it's going to be the same answer. I'm starting at the origin, and I'm just moving whatever the radius is straight to the right, and I'm stopping. Well, since the radius is equal to 1, I've moved 1 unit to the right, and I have not moved up or down at all. So if I start off at the origin and move 1 to the right, I've moved 1 in x and 0 in y. So the coordinate right there is just 1, 0. And then if I go to the left instead of up, I've actually moved a negative value. So my x is negative 1 and y is 0. Now let's go up. If I start at the origin and go up 1, well, I have not moved left or right at all. So I'm still at 0 for x, but I've moved 1 up, which gives me a y value of 1. And then finally, if you start at the origin and move down 1, you'd have 0 for x and negative 1 for y. And then that completes the unit circle. In the next video, I'm going to fill out the same exact unit circle, but I'm going to do it much faster.